Hello, everybody. My name is Qing Yang. I'm sixth PhD candidate in University of Georgia. Today, I will introduce my paper, How Can Robots Trust Each Other for Better Cooperation? A relative needs entropy-based robust robot trust assessment model. So I will separate 5 parts to introduce this paper. First, let us have some background knowledge about this research. Actually, the trust is a very common concept in our human societies. It describes the interdependent relationship between agents, which can help us better understand the dynamic of the corporations and the competitions, the resolution of the conflicts, and the facilitation of the economy exchange. And the red picture, I just give you guys an example to describe the relationship between each other in our societies. From another perspective, like the automations, the trust that describe the human automation relationships as the attitude that an agent will help achieve an individual's goals in a situation characterized by uncertainty and vulnerabilities. And from computing and networks angles, the concept of trust involve many research fields, such as AI, human-machine interaction, and communication networks. They regard the agent's trust as a subjective belief, which represents the reliability of the other agent's behavior in a particular situation with potential risks. From a more theoristic and application perspective, like the multi-agent system and multi-robot system, the trust by one agent, like the robots, on other agents reflect the trusting agent's mission satisfaction, organization groups, members' behavior, consensus, task performance at an individual's level. From system levels, the trust has been associated with the system levels analyzed, such as the reward and function at the organized group structure in a specific situations. So the very common application area is the in multi-robot system is the urban search and rescue missions. So in the rescue missions, especially the disasters, it can be regarded as life-saving, delivering valuable properties, and tackling crucial facility in disaster or emergency scenarios, which involve complex, dangerous, uncertain, unstructured, dynamic change, and adversary environments. So actually, multi-robot system working in such scenario require have a rapid response, higher adaptations, and strong robustness, which will largely help with the minimize the loss in the post-disaster scenarios. And the next part, I will briefly discuss the related work about the research. So actually, even the trust models has been studied from various perspectives and involve many different factors like the requirement, motivations, and performance, stuff like that. It is still challenging to develop a conclusive trust model that incorporate all these factors. And the future research into trust modeling need to be more focused on developing general trust model based on measures others than the continuous factor affecting trust. And actually, no work from the literature consider trust in social intelligence assistant from an artificial intelligence system perspective, like the robot, to model trust with the agent having similar needs and interest to the best of our knowledge. And current research also do not establish a substantial and clear connection between agents' behavior and motivations, especially the trust. For the approach in this research, actually we have several contributions. First, considering intelligent agents representing different needs in interaction, especially for the heterogeneous multi-robot assistant, we introduced a new trust model, relative needs entropies, based on trust assessment model to describe the trust level between agents and groups. It represents the similarity of agents' needs. Then we propose a hierarchical approach for RNE trust-based formation of the groups in a heterogeneous multi-robot assistant. This approach first from the homogeneous agents subgroups, then hierarchically merge according to a specific sequence until forming the final heterogeneous groups combinations. Here, I will give you guys some background knowledge about this approach. First is the relative entropies. So actually, the relative entropy is a measure of distance between two different distributions. In statistics, it arrives as a perspective logarithm of the likelihood ratios. So the other is the robustness hierarchies. Actually, it is our preview research is described the agent's needs as a needs expectations, which can be calculated through its behavior with and corresponding safety probability based on the data of the perception and communications. According above the discussion, we define the relative needs entropies, the RNE, as a difference and a distance of the needs distribution between agents in a specific scenario for an individual or groups. So actually, since the entropy is described the chaos of the system, so a lower RNE value means that the trust level between agents and groups is higher because their needs are well aligned and there's low difference in their needs distributions. So, and we also defined 3 kinds of the situation using our trust models. First is the trust between agents, then the trust between agent and group, and the last scenario is the trust between groups. In the evaluation part, we choose the Unity game engine to simulate the RNE model in the robust and urban search and rescue missions. And we consider 6 carrier, 4 supplier, 2 observer in total, which separate into 2 equally numbered subgroups executing 2 complex tasks in a post-nuclear rescue mission to rescue the resources and valuable items as much as possible within a limited time period. And considering the various individual agents' needs in a different situation, we organize their needs as follows, like the safety needs, basic needs, capability needs, and teaming needs. And this picture just represents the scenario in our simulations. And this is the video about our simulations. So actually at the initial state, all the robots just separate in the 2 groups based on their initial needs distributions and go to the corresponding task. I mean, with the low level needs group maybe will go to the easy task. and the more reliable group will go to the challenging task. And every time they back to the initial position, will regroup based on their current need distributions. And this is the performance of the comparison of the different grouping model in the USAR missions. So actually comparing with the state-of-art method, like the distant energy and the HP with the distance, the RNE model have a good performance compared with other methods. Yeah. So for the last part, I will briefly discuss our research. So actually we introduced a general agents trust model based on the relativeness entropy RNE to measure and analyze the trust level between agents and groups, representing the similarity of their diversity needs in a specific situation for heterogeneous multi-robot corporations. And we also illustrate how the RNE trust can be used in multi-agent decision-making applications. So for the future work, actually trust based on the relativeness distribution represent new opportunities for improvements, and also implement in the real robots is a very interesting and challenging research. And our vision is that develop more harmonious multi-robots team in the futures. Okay, thank you much. This is our paper presentation.